Now, let's have a quick discussion about pumps in series and parallel arrangement, since kailangan natin siya dun sa system requirements ng natin din-design natin ng pumps na required to the system. Now, this is, yung makikita nyo, is a typical design of a pump series arrangement. So, the volume flow rate is passed on the second pump. So, in this type of arrangement, it must be to ensure that the pumps have the same capacities. So the volume flow rate, let's say this is your pump, for example, this is your pump 1 and this is your pump 2. So the volume flow rate of your pump 1 is equal to your volume flow rate of your pump 2. Now, so they have also the same RPM. So we have your RPM of your pump 1 must be also equal to the RPM of your pump 2. Now, ang pinagkaiba na lang in terms of head nito, we have your head, which is your total dynamic head, TDH, now is equal to the sum of the total dynamic head of this one and this one. So it will be TDH of your pump 1, so that will be added to the pump, also added yung 1 and 2. So we have your total this is total dynamic head already. Now, ang kagandahan using in this type of series of arrangements of pump is that you can achieve higher pressure discharge, no? For some, dito sa arrangement natin, no, we can use also, pwede natin gamitin yung mga previous types of pumps, which is, mapapansin mo dito, we have this is 80, no? It does not suffice. So we have 85, 95. We can sum up yung total dynamic head niyan so that we can achieve yung volume flow rate. Yung volume flow rate, the requirements. Now, going back, so ito yung advantage ng using of series pump series arrangement. But mostly, this is not mostly advisable to use because of the complicated system. Since ang system natin, but later on, we'll discuss yung tinatawag natin na we have this type of pump is yung vertical multi-staging pump. So we have the type of pump wherein you have multi-series of blades inside your pump, and you have the same motor. So you also have the same RPM, but you have series of pump impeller arrangement in order for you to have a greater in order for you to have a higher total dynamic head or a higher pressure discharge. Now, yung sinasabi ko na multi-stage vertical inline pumps, ito yung itsura niya, no? So, mapapansin nyo dyan, so we have the series. So, if you're going to zoom, let's try to zoom on this area. So, this area, no? Let's try to zoom on this part. Okay. So, you will notice here, we have here the series of blades. Okay. So, low pressure, increasing pressure, increasing pressure, increasing pressure. So, stage 1, 2, 3, and 4. You have 4. For example, this is a 4-stage vertical inline pump. So, the purpose of this one is to have a greater capacity of total dynamic head. So, yung head mo, total dynamic head are increases. And you have the same RPM which is connected in one shaft. Mapapansin nyo, you have one shaft connecting through the electric motor. So you have the same RPM, same horsepower, but you are making increases the total dynamic head. So for example, here we have 1, 2, 3, 4. So if you have 4, basing on this type yung arrangement natin, going back yung pump 1, pump 2, so mapapansin nyo, we have here 1 and 2. Then your total dynamic head mo nito, ang mangyayari niya, ng TDH mo yan, it will be is equal to total dynamic head of your M-filler 1 plus total dynamic head of your M-filler 2 plus total dynamic head and 3, and so on, until you reach at the 4. So that will be the total dynamic head ng pump na ito, at the same RPM, and also at the same volume flow rate. So yung volume flow rate mo, constant, but yung total dynamic mo increases per staging. So ito yung tinatawag ng nowadays. So this is the arrangement nowadays that is making it compact, rather than installing another pump here and another one pump here, another pump here, and then and so on if you want to increase the head. But this type is more compact at the single yung footprint niya is maliit lang so that's at the single installation, so you can achieve a higher discharge pressure, a higher total dynamic head, di ba? So yun yung nowadays na which is available in the market nowadays. So ganitong klase yun. So this type of pumps are figure na ito was taken from the manufacturer, yung Golds, no? So Golds pump. So this is the Golds itsura ng mga Golds vertical inline multi-stage. So there is also another type of pump, yung vertical inline, which is ang kabaliktaran naman ito, multi-stage horizontal inline. When we say horizontal naman, this is vertical, patayo. Now, when we say horizontal, nakahiga naman siya. And also, again, it is in multi-staging. So, different series of blades that is attached in one shaft and one electric motor. So, this is, ito na yung nagre-represent ngayon ng mga pumps in series arrangement. Kaya tinatawag na siya na multi-staging, comparing yung ganito. So, ang kagandahan, compact in size, maliit ang footprint. So, in terms of installation, so isang area lang rather than using another pumps in another electric motor. In here, we have, since ang electric motor mo naman, ang kailangan mo lang din, same RPM and same horsepower lang din naman siya. Okay. Now, let's go to parallel pumps in a parallel arrangement. So, this is defined as when the pumps are in parallel arrangement, so pumps handle the part of the flow rate because the inlet of the pumps as well as the outlets are coupled together. So, thus, the total flow rate passing through the system is equal to the sum of the flow rates passing through the individual pumps at the given head, which is the same for each pumps. So, for the parallel arrangement, now, yung volume flow rate at pump 1, so we have the total, volume flow rate at pump 1, that will be the sum of volume flow rate of pump 2. So you will add. So it's a combination. But yung our head, or yung, let's say, your total dynamic head, it will be your TDH. TDH of pump 1 is equal to your TDH at pump 2. So I will show you my previous project. So this one is I've done the installation here. So this is a project I have done here in the Puerto Princesa, which is used for constant pressure system for 2-floor hotel system and 2 floors we call this 2 floors rental system or office system. So for that type of occupancy. Now you will notice here I have a pump 1 here, pump 2 here, pump 3. So our volume flow rate here, pump 1 and pump 2 and pump 3 are used to call it an equal volume flow rate. But if you will have the total volume flow rate of this one, it will be the sum of the pump volume 1, 2, and 3. The purpose, this is the purpose for the summing up of the total volume flow rate. So one way is to just only to conserve energy. So that is different in this type of discussion, since we are now in considering only the type of pumps in series, pump in parallel arrangement. So this is the type of arrangement that I have done installation. Okay, so ang mangyayari dito, ang total mo nito, ang total volume flow rate mo, so that will be yung volume flow rate ng pump 1, so plus yung volume flow rate ng pump 2, plus yung volume flow rate ng pump 3. But yung total dynamic head mo are equal. So yung total dynamic head ng pump 1 is equal to total dynamic head ng pump 2 and is equal to total dynamic head ng pump 3. So they have the common discharge. So discharge nito, discharge niyan are equal. Now, so that yung advantage of using pumps in parallel arrangement. and yung kanina is yung series arrangement. Now, balikan natin yung graph na ito, yung pump characteristic curve. So you will notice here, ang kailangan natin is 60, no? So we need 60 liters per second. Yung volume flow rate which is required 60 liters per second. Now, ang problema is the model 2509 cannot reach to 60 liters per second. But ngayon nga, we can use yung tinatawag na, but kaya niya palang i-reach yung 95 total dynamic head, which is 95 meters. So it falls dito. So pasok siya. But we can use the type of arrangement, yung tinatawag na pumps in parallel arrangement. Now, referring to this one, so we can use 20. So, if you're going to divide yung 60 liters per second, so that is equivalent to 3 pieces of a model 2509. So, if we're going to plot this one, so we will draw a broken line natin dito. So, we'll draw that one. So, for 20 liters. So, pasok siya sa, pwede natin gamitin itong 20 liters. So we can use your 20 liters. If we're going to draw a line dito, wait. So we have here 20 liters per second. Okay, we can find the intersection natin siya somewhere here. So it falls via yung pump na 20 liters per second. So that is 63 and 65%. So we can use a 64%. Para dito, yung pump efficiency. Now, we can use yung type of pump of arrangements, which is yung parallel type of pump arrangement para ma-suffice natin yung design. So, ma-comply o ma-attain yung requirement ng design. So, we'll be using 3 pieces nito, 3 pieces of this one, model 2501. So, since yung ang pump natin required to deliver 60 liters. Okay? So, our pump requirement shall be given. Now, I will select a pump. For our pump selection, we have the pump model that is 2509. So, FI and CI series. So, with a given 20 liters per second. So, our volume flow rate, that will be 20 liters per second. Ito yun. Dito yun, part na yun. Then, with the corresponding total dynamic head, which is 95 meters. So, it falls on the 64% yung efficiency ng pump natin. If we try to compute yung horsepower niyan, let's say that will be yung, if you can we have here yung pump efficiency, so that will be the water horsepower divided by your brake horsepower, or let's say that will be your electric motor, so that will be E motor power. So if you try to compute yung electric motor, so E of your motor, or the power that is being generated by the motor, so that will be your water horsepower, then divided by the pump efficiency. Now your E motor, so our E motor now is equal to the that will be your specific weight, total dynamic head, times yung for the water horsepower, that will be specific weight times the volume flow rate times your total dynamic head, then divided by the pump efficiency. Okay, so let's continue resolution dito. So let's try to substitute yung values here. So we have specific weight, so that will be 9,810. So that will be Newton per cubic meter. Then we shall multiply yung volume flow rate. So that will be ilan ba yan dito sa atin? So that is 0.06. So that is 0.06. That will be cubic meter per second. Then we shall multiply it by total dynamic head, which is 95 meters. Then divided by our pump efficiency, which is equal to that is 64. That will be 0.64. So we have the motor horsepower na or electric consumption of our electric motor. So I have, that will be 87. So this is Newton cubic meter, cancel out in Newton, cubic meter. Then we have Newton meter, so that is already in units of watts. So I have 87,370. So that will be 0.3. That will be Newton meter, unit Newton meter second. So that this is already in watts. So if we're going to convert to horsepower, we have 1 horsepower is equivalent to 746 watts. Okay. So I have 117 horsepower requirement tong ano na yan, pump na yan. So let's check yung pump characteristic curve niya. Okay. Able to compute 117 horsepower, which is the electric consumption basing on a 64% pump efficiency. So mapapansin nyo from here our pump characteristic curve. So this is falls in the 40 horsepower. Okay. So it's so confusing, but anyways, we still be using 117 horsepower. So that will be the electric consumption if we are basing a 64% efficiency of your pump. Okay, so that concludes yung pump selection natin dito. And also, by referring yung pump characteristic curve na ito, so kanina, we're trying to refer, so mapapansin ninyo, so the total dynamic head, which is already yung type of pump of this series, itong series model 309, if you can see, we are in the 100 horsepower already, falling near the 100 horsepower. So if you're going to continue this curve of pump, so this is already fall in the horsepower of 100 plus. So I think we are in the right path, no? Baka there must be error on this type of pump characteristic curve of this one. But referring on this one, so if you're going to refer, this is the 100 horsepower. If you're going to continue the pump characteristic curve of this impeller, no? So we will maybe achieving 100 plus. So if you're going to continue this one at 20 liters per second at this given total dynamic head, so if you're going to plot that one, so you will still be reaching maybe near to the 100 horsepower. So since this is already 100 horsepower. So okay. So that is the method of how to conduct a pump selection method. So you can use this one as you go to work in daily in your design basis and also in your pump installation basis. Okay, so that